It always works. But you do. You know what you are doing.
But you still have the square root there, so you can get the one.
No, because you can't, because
that would be
2 to 25, that's because it's also it's like a root of 2, so there's
would that be 10? Would that be 10? 10?
You're demoted.
It's only a matter of time.
All right. What is the answer to the first one? Done. No more radical sign. Y. What is the square root of 25? 5. So out comes 5. X to the fourth means there are 4 x's under there. A 2 means I'm looking for groups of 2, correct? So out comes 1x. Out comes a second x. X squared. 6, I'm looking for groups of 2. I can get out 3 groups of 2. This one, what is it going to be?
4xy squared. So the cube root of x squared y.
Close. 2xy squared cubed root. Keep going, Justin.
Then it's 2x squared.
2x squared y. That is the right answer. Y. This is 8 times 2. What's the cube root of 8? 2. There it is. How many groups of 3 can I get out of 5? 1. So there's 1x, leaving 2 x's under the radical sign. How many groups of 3 can I get out of 7? 2 groups of 3, leaving 1 y under the radical sign. Please notice there is nothing new. When we were working up here, it was just this became root 4 times 4 times 6. So I brought out the group of 2. So when it's variables, you are just bringing out groups of variables. Everybody good? That is how you simplify a radical, even complicated ones. If you're having trouble with that, then the next few days are going to be very trying for you. So make sure you are comfortable with that. Jorrit, was that your hand going up or are you just stretching? Okay. So I left you here with these. That doesn't change. We are on page 31. That is 14. That is 6 cube root 2. That is, holy crap, that's hard to do in my head. That is 125 times 30, which is 5, no. That is 125 times 30, which is 5 cubed times 5 times 6. So that is 5 fourth root 6. If you need to stop me, what are you to do? Stop me. And I will explain further. This is what I did in my head. If you can't follow it, you don't know how I got to here, you stop me. That is 81 times 4, right? Isn't it? Yeah. Isn't it? No, that's not right. That's 96 times 4. Yes. And then that is 16 times 6. So that means I'm going to get out a 4, and the square root of 4 is 2, so I'm going to get 8 root 6 there. That is 10 times 18, which is 5 times 2, and 9 times 2. So I'm going to get out the root of 9 and a 2, so I'm going to get a 6, negative 12 root 5. Everybody good? Noah. F? Okay. Well, I break down the 180 however I see fit. So for me, I took 180 and I did 18 times 10, then 9 times 2, and then 2 times 5, right? Square root of 9 is 3, so out comes a 3. Then I had a group of 2, so out comes a 2. There was already a 2 out there. 2. 2 times 3 times 2 is 12, and it all has to be negative. And I left a 5 under the radical sign. Now, this question. I gave you all the answers. 8, 10, and 12. So, area was the square root of S, which is the half perimeter. Well, if the sides are 8, 10, and 12, then the triangle is 30, right? What's half of that? So it's 15 times 15 minus A. 15 minus 8 is 7. 15 minus B is 5. 15 minus 12 is 3, right? So, as a radical, it is, this is 3 times 5, correct? Everyone agree? There's a group of 2. There's a group of 2, right? So what comes out? A 5 and a 3, and what did I leave under there? 7. So as a radical, it's 15 root 7. That's the mixed radical. As a whole radical, it was 15 times 15, which is 225, times 7 is 200 times 7 is 1400. 7 times 25 is 175, so 1575. And then we just had a few to simplify. We already know that is 16 times 6, so it is 4 root 6. That is 121 times 2, so it's 11 root 2. That is, we already know that to be 6 root 5. But there's 2/3 out there, so it's negative 4 root 5. That is 32 times 10, which is 16 times 2, and 2 times 5. So that's going to be 4, and 2 is 8's coming out. 1/8, 8 times 1/8 is 1, so that is root 5. Yo. Okay. We know that this, if the 2/3 wasn't there, this is 36 times 5 to get 180, right? What's the square root of 36? So out comes a 6 root 5. But there was already a 2/3 out there. These are coefficients, so what math do coefficients do together? What? 3x. What is that 3 doing to the x? Multiply. So what math do these do? Multiply. So negative 2 over 3 times 6 over 1 is negative 12 over 3. And negative 12 over 3 is negative 4. Same thing here. This is 64 times 5. So out comes an 8, but there's already 1/8 out there. 8 times an 8th is 1. We don't write 1, so it's root 5. Right? Okay. 245 is 5 and 49. So that is 7 root 5. 338 is, what is it?
I got 1, 2,
What? Oh yeah, 169 times 2, so that's 52 root 2. 1250 is 125 times 10, which is 5 times 25 times 5 times 2. So that's 5 and 5. 25 root 2. 66 is nothing. 11 times 6, there's no groups. That stays the same. 304 is 152 times 2, which is times 2 is 76 times 2, which is 38. Oh, what a pain, which is 19. So it is 4 root 19, but that negative 20 over 6 root 19, which is reduces to 10 thirds. Negative 10 thirds root 19. 980 is 98 times 10, which is 2 times 49 times 10, which is 2 times 49 times 2 times 5. So I bring out a 7, I bring out a 2. 14 root 5. 272 is 136 times 2, which is 65. 68 times 2, which is 34 times 2, which is 17 times 2. So that is 2 comes out, 2 comes out. That is 16 root 17. 288 is 144 times 2, so that's negative 36 root 2. 369 is, look at that, 1, 2, 3. That is 123 times 3. That is 41 times 3. So that is, out comes a 3, 6 root 41. Somebody has that done. 491. What?
491 words.
Oh, 4 and 91.
Yeah.
Okay, so that's 2 root 91. 450 is 45 times 10, which is 9 times 5 times 5 times 2. So out comes a 3, out comes a 5, that's 15. 30 over 5 is 6 root 2. And that is 341. Doesn't divide by 3, doesn't divide by 7. 7 times 4 is 28. And 341 can't be a prime number, is it? It is? So that one's done. Test on Friday? No. This is all second unit stuff. Now, ladies and gentlemen. What? 31 times 11? Yeah, but 31 and 11 are both prime numbers, so there's no pairs to come out. So it's not prime, but it doesn't simplify. All right. Now, I am guessing, and hear me when I say guessing, I am guessing that a great many of you cannot simplify these as quickly as I can. Is there any prize in this class for finishing your tests quickly? No. So do you need to feel poorly about your math skills if you cannot simplify the square root of 1,250 as quickly as I can? No, because the only thing you need to be able to do is get to there. If you can get the answer, you're great at math. All right? Speed means nothing. This is not the Mathlympics. All right? No, because if it was the Mathlympics, then 27 of you would fail. Because only 3 people in the Mathlympics get a prize. Gold, silver, and bronze. School is not like that. Everybody wins in North American school, Jack. Everybody. You all get your gold ribbon, gold star, trophy, everything.
know people who would be failing.
Yeah. Everybody turn to 33, please. Again, today you already know how to do this, so we are only going to add a small wrinkle to it. You don't even need me to teach you how to do this because you already know. Forget about the word radicals for a minute and just cast your mind back to the 9th grade. 3x. What does that mean? There's 3 times x, right? So this is if x equals one of these good old-fashioned algebra tiles, how many would I need to draw here? 3. Right? Then I have 2x here. What does this equal? What would I need to draw? 2 of the bars. And I would end up with, red and blue makes purple, 5 x's. Because I would have 1, 2, 3, 4, 5 x's, right? Now, in math, if you were to take this purple expression and read it to me in English, what would you say? Just tell me that in English. 5, what was that? 5 times x. Agreed? And in math, we know that 5 is a coefficient. And the x has lots of names, but once it's put into this situation, we call it an argument. Okay? So whenever you are faced with something that looks like this, it is the coefficient times the argument. Agreed? So, if I am dealing with radicals, mixed radicals, 5 root 3. If I were to say that in English, what would it be? 5 times the root of 3, correct? And I would have to draw this root 3 5 times. Do we agree? Now, if I also had 2 root 3, how many times would I have to draw root 3 over here? Twice. Giving me a total of how many root 3s? 7. That's all we're doing. If the radicals are the same, then it behaves just like this situation. And that's it. Doesn't matter that it looks different because it's still coefficient times an argument. Everybody good? So let's look at that first super easy one. They're not all the same. So can I do anything with that guy? No. So if this was in x's, it would be 5x minus 3x minus 4x plus what? No. We're changing it to letters. What would it be here? It would have to be y because it's different. So we do it just like we learned in the 9th grade when we collect our like terms. That is 5 minus 3 minus 4 root 7 plus root 2. 5 minus 3 minus 4 is negative 2 root 7 plus root 2. And that is all you do. Everybody cool? Now, can you forget about your previous 11 years of math? No, you cannot anymore. Up to grade 10, you could forget a whole bunch of stuff. In grade 11, you need every single thing you've ever learned. In grade 11, if I faced you with just that, what would you do? Hint, it was yesterday's work. That would be 16 times 2. So that would be 4 root 2, correct? And if I faced you with just that, what would you do? That would be 4 times 2, which would be 2 root 2, correct? Well, you've got them both together, so you add it to get what? 6 root 2. What is the rule to remember there? The same rule that you have been told to remember since grade 3 when you were taught to simplify fractions. Simplify whenever you can. Sometimes at the beginning of the question, sometimes in the middle of the question, sometimes at the end, sometimes in all 3 places. Never be not simplifying. Rhea.
Is that a 9 or a 4?
That's a 4, because this was 16 times 2. 4. Everybody good? That's the entirety of the point of this whole lesson. So what am I going to do here? Can I do anything right now? So what must I do? Simplify, simplify, simplify. That's 4 times 7, right? That's 9 times 7, right? And what's that? That is 16 times 7. What's coming out here? What's already out here? So what's left? 10 root 7. What's coming out here? 9 times 7. What's already out there? So what's the answer going to be? Negative 9 root 7. What's coming out here? 4. What's already out there? So what's going to be there? 8 root 7. Do I see root 7, root 7, root 7? So what do? I treat it just like it was 10x, 9x, and 8x. And I add it up. What's 10 minus 9? What's 1 plus 8? 9 root 7. Easy peasy lemon squeezy. 4 times 5, 9 times 5. 2 root 5 minus 9 root 5. What's the answer? Negative 7 root 5. You don't even need to worry about your calculators. It's that easy. Will it get any more difficult?
Yes.
Maybe.
Will it get any more complex?
Yeah.
Yes. Will it get any more difficult? No, because you will follow the exact same methods. Is this one easy? I can't do anything with it now, so what should I do? Simplify. 2 times 49. What comes out? 7 root 2. 4 times 5. What comes out? 2 root 5. 18. What comes out? 3. Plus 3 root 2. Can I do anything there? 7 root 2s and 3 root 2s. How many root 2s do I have? 10 root 2s and 2 root 5s. Yes. Is there, well, technically, I have added negative 2 root 5s. Any questions? It's never more difficult. It's only more complex. What's going to be different about C? It's cube roots. So what my simplification process is different because I'm looking for groups of what? 3. But I can still add 2 cube root x plus 3 cube root x is what? What do you think that's going to be? 5 cube root x. Now let me ask you this. Can I do this? Why not? The index is different. The cube root of x is different than the square root of x. So they are no longer like terms. That is important enough to get a Mrs. Bad Crumble Cloud around it. That doesn't work. because of the different index. Just like you couldn't do 5x squared plus 6x. Because x squared and x are different values. Okay? Okay. I want to see what is going to happen in D. How far back do you have to go in your math memory to do D? All the way back, because what are you adding there? Fractions. Blech. But you can all add fractions. Yes, you can. Don't be that way. You are working until page 36. I know, right? The more astute members of the class, what you see comes right after 2.2.
2.2. 2.3.
Quiz. Do we call them quizzes? No, we don't want to hurt your feelings. So we are going to call this one a oobleck. We are going to have an oobleck. Because that's from Dr. Seuss. And who doesn't love Dr. Seuss? Crazy people. An oobleck on radicals. Yes, it is the slime that falls from the sky. Starts out the size of grape seeds.
What is Snickle Fritz?
The oobleck on radicals. When could it occur? Could it occur tomorrow? Why not, Jack Anderson? It's like you've been in my brain. Get out! Because you're going to be preparing for your test on Friday. Why would I give you a quiz on this tomorrow? Will you have seen the right answers? No, not until tomorrow. Will you have had a chance to study your right answers? No. So the quiz couldn't possibly happen tomorrow. Could it happen Friday? No. Why not, Jack Anderson? Because we have a test on exponents on Friday. Could it happen Monday? If I so chose. So your oobleck on radicals will be sometime on or after Monday, Feb 11. Okay?
We only have a 3-day week next week.
Okay. You do only have a 3-day week next week. Then you get a 5-day weekend.
That's definitely a big fan of that.
Snickle Fritz.
A Snickle Fritz is what the grade 10s pretend piece of work that has no use of notes or help on it called. Josh, and you have been around my class long enough to know that as soon as I write the word quiz on something, people can't do it. Even though if I called it a worksheet, everybody would get 100% on it. Soon as the word quiz is written, all of you flip out for some strange reason. I don't understand it, but you all do.
Did you end up taking these books? The one
Uh-huh. I did.
on Monday, right?
When we did the quiz. People wrote it on the quiz.
I wasn't there that day.
Well, then you're going to have a very low grade in this class right now, aren't you? How could you solve that problem?
And I had my worksheet.
Yes, you can. And if I am not mistaken, I had checked my mark open. Now, it is your time to work. Are you allowed to move around? Yes. Are you allowed to listen to music? Yes. As long as